I hope you have made yourself comfortable, maybe on a couch, maybe with a cold drink in your hand, and I hope that you enjoyed the music. It was composed by Tareen Zafran. The American singer-songwriter uses AI to help generating percussion melodies and chords. So is AI taking over deeply human capacity like creativity? This is just one question we want to deal with during our couch lessons. Every week, always on Wednesday, we invite experts from all over the world to discuss the risks, the challenges, but also the opportunities presented by developments in the field of artificial intelligence. The couch lessons are funded by the Federal Foreign Office and organized by the Goethe-Institut, the worldwide active cultural institute of the Federal Republic of Germany. We promote the study of the German language abroad, and we encourage international cultural exchange. With the couch lessons, we want to initiate a discussion outside the technology-savvy community. We want to question what AI is and what it could and should decide in the future. We also want to ask if there is a way, maybe a European way, beyond surveillance and commerce, because a lot of developments in the field of AI are economy-driven so far. It's all about power and money, or isn't it? The Goethe-Institut deals with AI because this technology has and it will have a huge impact on our society at different levels and in various fields. AI will contribute to a new revolution in human history, and it is already a part of our everyday lives. It shows us the shortest route to our destination, and it calculates which films, which books or songs we might like. But that's not all. Algorithmic decision systems are also used by governments to determine the risk of prisoners relapsing or the probability of unemployed people to find a new job. We think that a future generation, a so-called Generation A, will even have a job interview with an AI. About this topic, we will talk at our upcoming couch lesson about AI and the future of work. Today, we are dealing with AI and intelligence, and we have prepared a little poll for you. Wait a sec. So, do you think that AI can become as intelligent as a human being? As long as we wait for your answers, I would like to inform you briefly about some guidelines of the couch lessons. First, our two experts will give an input, each about 15 minutes long. And after that, we will open the discussion. During the whole time, you can ask questions or contribute your opinions in our chat. I will go through the chat and pick out some questions that will be discussed later. I will ask different persons to contribute their questions or thoughts personally, but if I don't ask you to talk, please turn off your microphone. I also want you to know that the entire event is recorded, but we will just record the persons that are speaking. You can always turn off your video, although we would invite you to switch it on so everyone can see all the participants from all over the world. And for that, we would recommend to use the gallery view. So let's have a look on the results of our little poll. I hope you can see it. No, never, only 11% said yes, but only in relation to specific tasks. Most of you think that this will happen. And of course, yeah, 25%. And with this results, I will hand over to my co-host Martin from Sweden, who will moderate the lesson and who helped me to curate the whole series. Thank you for listening.
Hello, everybody. As Jeanette said, I am Martin Törnqvist, and I'm a curator and context maker based in Malmö, Sweden. Before we start, I just want to, all of us to sort of take a moment to acknowledge the fact that we've decided to gather in this lonely togetherness in front of our screens, calling in from all over the world. If you feel like it, please go to the chat and say hi and type where you're, what part of the world that you are joining in from. That's always a nice sort of contextual way to get to know each other a bit. And so in curating this series of couch lessons, it's been important for us to go to the roots of the technology and to enable or to make deep dives, to enable us to make deep dives in opportunities and problematic aspects that will follow. We have sessions lined up on topics such as ethics, creativity, human-robot interaction, and climate change. But today we want to do something of an introductory class about what technologies that the somewhat sloppy term AI comprise of. Our hope is that a better understanding of artificial intelligence will also make it more possible for us to be AI literate. So we're going to ask questions such as, what's the difference between machine learning and deep learning? And why does the size of the data sets that we're talking about matter? And in the process of curating this session, Jeanette raised a question that was too intriguing for us not to answer. And she said, to understand what artificial intelligence is, mustn't we also discuss what intelligence is in the first place? And I thought that was a fantastic question, and so we decided to go ahead. So with us today, we have two extraordinary experts who will try to break the concepts of AI
Hi Daniel,
and intelligence
Svenja
apart
hier.
for us.
Cool, dass du sofort abnimmst. Ich habe eine Frage, und zwar
Yeah, so we have two extraordinary experts who will try to break the concepts of AI and intelligence apart for us, and maybe also debate at the end the different perspectives and objectives. So let's get started. I'm not sure if you can actually see my face. Is it mine? That doesn't really matter. I'll continue. So first, I want to welcome the machine learning researcher Nell Watson. She's calling in from Belfast, Northern Ireland. She will give an overview of what technologies is embedded in the term AI, how it's already being used, and what we can expect going forward. Nell is a member of the AI faculty at the Singularity University. She serves as the chair and vice chair, respectively, of the IEEE Transparency Experts Focus Group and Transparency of Autonomous Systems Committee on AI Ethics and Safety. Nell, feel the appreciative energy from everybody being with us today, beamed to where you are. And please unmute your microphone and the screen is yours.
Thank you very much. It is an absolute pleasure. I'm going to just set things up and hopefully we're good to go. So this will be generally a primer, an introduction to machine intelligence, its different dimensions, and a little bit of what you can do with it and how accessible it is to everyone today. Consider this example. We have an older gentleman going to visit his doctor, and his doctor reckons that he has an excellent sense of health. His heart is doing very well, and everything seems very fine, except that an algorithm can detect a very slight signature in how his heart operates and can predict that that gentleman is going to have a serious health problem within 2 years. Because of that prediction, this gentleman's life and well-being is able to be preserved because that algorithm was interpreted by a medical professional. So we have machine and human being working very nicely in concert. How does this happen? How is machine intelligence able to pinpoint things that even a very skilled physician with decades of experience might not necessarily notice? In essence, our universe is filled with correlations. Some of them very simple and obvious correlations, such as one side of our face is usually similar to the other side of the face, or the people with big hands tend to also have big feet. But some correlations in our world are much more complicated. They are harder to understand. They are sometimes things we would only necessarily feel from our intuition. We wouldn't necessarily be able to put them into words. We know something on a deep level, but we cannot necessarily explain why or how we know it. In essence, it is these kinds of difficult to understand correlations that machine intelligence is very, very good at finding. It can help to bring these things to the surface, to help us to understand this strange world hidden beneath the surface of the universe. And that's why it's so important. It enables us to make sense out of chaos and to automate the ineffable. Ineffable meaning those things that we cannot put into words, we cannot put into language or even mathematics, but we know it when we see it. And that's what machine intelligence is all about. Now, this is not the AI of our grandparents. That was very different. Every single possibility had to be programmed in, and every potential scenario had to be understood in advance. And this meant these forms of AI were very inflexible. However, from around about the 1980s, we started to get a subset of artificial intelligence called machine learning. This is about teaching machines to understand the world by giving them virtual experiences. In essence, there are three different ways of teaching an AI about the world. And they're similar to how young children learn as well. A young child might learn about the world in a structured environment where there is a curriculum of things to be learned. This is what we call supervised learning, where you give basically an instruction and say, this is an apple and this is a banana. And you teach things very directly. Then that child in school might go outside into recess and enjoy the sunshine and explore the world, play with leaves and look at the clouds in the sky. And this is not a structured form of learning. This is an unsupervised form of learning. And we can use this to teach machines. We essentially give them input and enable them to make sense out of it as they wish. So we don't teach them what a cloud is. We just allow them to develop their own perception of what a cloud is. Then there's reinforcement learning, a method of kind of carrot and stick, where you give positive and negative feedback as a system or a child or a pet learns to do things which are more preferable and is dissuaded from doing things which are less preferable. So these three mechanisms enable machine learning to be very sophisticated and to learn about the world for itself. In recent years, we've seen the development of deep learning, which is much more sophisticated. It is able to cope with very complex elements together. For example, in this picture here, it's a very fuzzy kind of picture, like you might take on your flip phone camera 10 or 15 years ago. But we can actually restore information that was never captured in the first place. We can rebuild lost information as if you were kind of peering through the curtains of the universe to find that information hidden there. In essence, deep learning is about making sense of very complex variables in many different layers, layer after layer, rebuilding things over time. A few years ago, I was working to solve this very difficult problem of how to capture 3D body information in a simple way. It's very difficult to capture 3D information of people, especially. It's a little bit like an old photograph from 150 years ago. You have to be very still for a long time. I developed some algorithms to help to process 2 photographs and to reconstruct them into a 3D image. So you could just do this from 2 snapshots on your smartphone. But there was one element that was very, very difficult. We tried to program it, but the programming was too complex. We tried to program an element that would extract the person from the background, because you don't want to be measuring the background, just the person. And you'll see here that it doesn't quite match up on the girl's arms. And so we would write all of these routines to try to segment the head, the feet, etc. And we would get one thing to work and the other thing would break. It wasn't a sort of problem that could be easily programmed into machines. However, we took a machine learning approach. We fed in lots of images of plain pictures, and then we segmented them naturally within Photoshop by hand. And so we had 2 data sets. We had the original image and the segmented image. And by putting these into a deep learning system, we were able to start to segment these objects automatically, just using machine learning. And now these technologies are being used for all kinds of object recognition in many different pictures, for example, with Facebook. This enabled us to create this method of measuring the body from just 2 photographs, thanks to deep learning. In recent years, we're starting to see a further development within deep learning called meta-learning. And this is one of the most exciting areas in AI in recent years. Here we have 2 little agents, the red ones and the blue ones. And the red ones are trying to get the blue ones, and that's why they blocked the entrances. However, if you put this ramp in there with the red ones, they figure out how to get over the wall and get inside to where the blue ones are. Pretty smart. And so what do the blue ones do then in this scenario? Well, they steal the ramp, of course. And then in this evolution, they have managed to protect themselves. Now, this is the first step towards a more generalizable form of intelligence. It's a way of working with data that is not specialized in any one area. It's kind of an amateur in lots of areas, but that gives it lots of flexibility and a more generalizable way of working with the world. Data is perhaps one of the most important aspects of machine learning. Just having a clever algorithm isn't quite enough, because even a very intelligent brain is only as good as the experiences that it has to work with. And as soon as we have data to train systems, they get rapidly very sophisticated. And we have a lot of data, because from the dawn of human history up until the year 2000, everyone who ever lived created about 5 billion gigabytes of information. However, thanks to the internet, thanks to smartphones, etc., we started doubling that amount of information every 10 hours by the year 2010. And presently it doubles about every 10 seconds. That is a massive increase in the amount of data in many different forms, whether it's visual data, whether it's audio data. All of this data can help to provide virtual experiences for AI to learn about the world. And this makes it much more accurate and much more flexible, much more able to deal with stranger situations. Meanwhile, a whole bunch of new clever algorithms are coming out all the time. Too many for us to even properly study. We're going to be trying to make sense of all of these new developments for a long time. And that's why I don't think that there's any kind of AI winter coming anytime soon. There's an old philosophical story about monkeys on typewriters. And if you had enough monkeys on enough typewriters, you could recreate the works of Shakespeare. In some ways, this is how certain advanced forms of AI are working today. there's a new technology called generative adversarial networks, which enables us to construct information which looks very, very realistic, and yet is not. It is generated, it is guessed into existence. It's where you have two AIs that go against each other. One of them is trying to make fake things, and the other one's trying to detect it. And this means that progressively, you can get a more and more sophisticated, plausible generation of, in this case, a human face that goes from something obviously not quite real to something that looks, bottom right, very realistic, and yet is not. And you can check out humanOrAI.net to learn more about these technologies and guess whether you're looking at a human or a bot-generated image. We can also do this with whole humans and all of the clothing that they're wearing as well. So these generative techniques are very sophisticated. We can take a sketch like you might draw in MS Paint and apply one of the styles of the great masters to it. And if you don't like where that bush is, you can move it somewhere else, and then voila, you've just painted your own masterpiece. We can bring masterpieces to life to give a little bit of spirit to them, that extra level of magic inside the art piece. We can imagine or dream an experience like driving in a car. This is not a real video, this never happened, but it looks quite realistic, and within 1 or 2 years, it will look basically indistinguishable from a real video. Of course, if you want to get really freaky, you can turn Superman's girlfriend into Nicolas Cage. The possibilities are limitless. Now, for more practical purposes, we can do things like generate a perfect bicycle frame given certain constraints, right? You don't want to use too much material or to have it too heavy. And so within those constraints, it can generate different potential solutions. And so you can evolve things over time, which are very, very optimized, very sophisticated. And yet they're almost biological looking, almost alien in how they function. We can even do this for things like 3D printing. We can 3D print a tooth to fit in a socket, even if we don't have the original for reference. We can do this with products as well. You can take a sketch like you might draw on a napkin over lunch and turn it into a realistic 2D or 3D object. And I think that our sense of aesthetics is going to change, because we used to have a fancy world, and then now today we have quite a straight and boring world. But with these technologies, complexity becomes free, because the design can be very complicated, but also the production through 3D printing can be quite simple as well. New technologies are enabling us to understand material science in new ways through machine learning, through these kinds of self-driving lab technologies that can imagine a material and then construct it inside the lab, whether it's an alloy of metal or a polymer of plastics, extrude it, and then test it. Is it brittle? What temperature does it melt? Does it melt at all, etc.? And this means that our material science is now advancing at a much faster rate than it otherwise was. We can use this within creative narratives as well. We can use this, you can check it out at aidungeon.io. You can basically type in whatever you want as a response, and it will generate a story to match what you've put in. We can also do this within programming itself. So rather than create code, we can simply specify in a comment what we would like to see and enable AI to generate the code for us. And of course, we can go beyond code. Now, some of the most sophisticated implementations of AI are in fact created by AI itself. So here we have, to some degree, a level of self-improvement, right? We enable AI to generate more sophisticated AI. Essentially, these elements mean that we can start to automate very complex cognitive tasks for the first time in human history. The great philosopher and logician Whitehead reckoned that civilization advances by extending the number of important operations which we can perform without thinking about them. And that's what we have today. And it means that civilization may be advancing, perhaps to a similar degree as the great leap that we had during the Industrial Revolution. And I think that's quite exciting, and a little bit scary as well. However, we mustn't get lost in all of these clever algorithms, because sometimes even very simple, basic statistical data science methods are almost as good as these very clever, smart systems. Sometimes even basic, simple, dumb data science can be just as good. So don't ever forget about that. So let's look at some of the business cases for AI. Here are some of the best use cases, particularly in fraud detection, enhancing customer service and customer modeling, or making business intelligence suggestions. A lot of people are concerned, therefore, that maybe AI is going to take our jobs. And generally speaking, I don't think that's likely to be the case. I think AI is typically there to replace tasks rather than jobs per se. It is there to be an assistant. And most jobs are far more complicated than any AI could reasonably take over for. However, in managing AI workforces, I recommend that we think of things in terms of tasks rather than job roles, and we analyze whether those tasks should be done better by a human or by a machine. In order to make sense of AI, it's very important to get good data in, and there are some great tools out there that can help you to label your data and to put it into a form that machines can make sense of. I've put some links up here you can follow as well to get more information on this robotic process automation. Essentially, in very simple terms, it's about capturing data, cleaning it up, and putting it in a form that machine learning can interface with. I recommend checking out some of these resources, deepindex.com and paperswithcode.com. These are great ways of understanding the state of the art within machine learning right now, as well as this website called SeedBank, where you can run AI in your web browser and watch as it improves things step by step and performs functions and makes things happen before your very eyes. Another link for you, tinyurl.com ML Crash Course is a great way to get going in applying machine learning to your business, as well as this resource here, datasetsearch.research.google.com, is also great for finding data to feed into your AI system. You can also use synthetic data. So for example, rather than using an address, a real address, you can create a fake one, like John Brown at 123 Happy Street. And that's sometimes enough to train a system without needing to use real data. I'm getting a little bit beyond time, so I'm just going to say, I'm going to recommend that you check out these books, Prediction Machines and Applied Artificial Intelligence. I think these are both very good books for understanding AI within particularly a business context. So that's all the time I have today. Thank you very much indeed.
Thank you very much.
Please do download the slides at that link as well. I'll put it in the chat too.
Fantastic. Thank you very much. And that was a lot of progress covered in 20 minutes, I think. Thanks for the cases, and also thanks for hinting to future couch lessons that we will be hosting on topics such as creativity and health. And to everybody following, please post questions in the chat and keep the the conversation going there in parallel to the talks. So the questions will be gathered by us, and then some of you will be able to ask them directly a little later. So we spent the first part of today's session looking at how much more efficient and capable machines has gotten the past decades. We're now going to spend the next 50 minutes with the second word in the abbreviation AI. Intuitively, it feels like taking a step back in doing so, but maybe discussing what intelligence is in the first place elevates our understanding of what it is and what it can become. With us to do this, we have Marcus Gabriel. He is a professor of philosophy at the University of Bonn, where he holds the chair of epistemology, modern and contemporary philosophy, and is the director of the International Center for Philosophy, as well as the Center of Science and Thought. Without further ado, beam a very warm welcome to Marcus Gabriel. The screen and microphone is yours.
Well, yeah, thank you very much for having me. It's a great pleasure to be here. And thanks to Nell for a wonderful presentation of some of the state of the art in very advanced AI and its applications. So my presentation will consist in trying to clarify the relevant meanings of intelligence and artificial in the context of AI debates. And in so doing, I want to address the question of the ontology of AI, where ontology means the mode of being. So where in the order of reality, right, do we locate AI systems, so-called AIs, right? And I will argue that there's a relevant and interesting sense in which there's no such thing as artificial intelligence, but of course there are so-called artificial intelligence systems. It would be crazy to deny this. And I think that the difference between human intelligence, the categorical difference between human intelligence and AI systems created by actually intelligent thinkers, such as humans, that very difference gives us some insight into how AI research and also AI technology progresses, right? So my ontological worries here, right, are not meant to limit AI research in any way. I just want to clarify where exactly it fits into the universe, and I will draw also, I will make some recommendations of how to further improve the field. So let me start with the concept of intelligence. My talk will have my presentation 3 parts. First, I will say something about intelligence in general, and then I will talk about the other component of AI, artificial. I will say a few things about human too, because we are human. So if we try to compare human intelligence and artificial intelligence, we better have also some understanding of what it is to be human. And then I will argue in the final part of my presentation that actual AIs and AI research provide us with thought models. And this is going to be like a crucial term for my presentation. So let's get started. So evidently, the English word intelligent and its cognates has many meanings. So if we ask the question, what is intelligence, right? We better say something about what we mean by that question, because the question is highly ambiguous. And arguably, so here's a hypothesis. I will not talk about how I derived the hypothesis. I can answer that later. If you're interested, I will just give you the hypothesis, right? So intelligence has at least the following sense, and let's call it the efficiency sense of intelligence, where a system S is more intelligent than another system S star if it can solve the same given problem in a faster, that is in less time. So in general, intelligence is the capacity to solve a given problem in a finite amount of time. In human beings, intelligence, like in other animals, is the result of evolutionary pressures. We only have so much time. I think we need to mute. Okay, good. So intelligence in animals clearly is a function of evolution. So we only have so much time to solve our problems because otherwise we starve to death. So what we do every day is you know, we are constantly, our organism is constantly solving many problems. Some problems are solved in a non-conscious way, such as, you know, the growth of new cells and so forth, right? I have no conscious or hardly any conscious influence on how my cells grow and my metabolism functions and so forth. So some processes in my organism, though intelligent, are non-conscious, and other processes in my organism, the conscious ones, can also be intelligent. Yeah? So intelligence in general is the capacity, let me repeat this, that's the notion which I call efficiency intelligence, is the capacity to solve a given problem in a finite amount of time. And now we can measure intelligence. There's the whole discipline of psychometrics, and this is all very intuitive because of course you can measure the performance of any given system given a certain task, you know, in time. So, you know, I give you a certain mathematical problem or a chess problem, and then depending on how you can, how fast you will find the best solution, right, you will count as more intelligent than some other system. So Garry Kasparov is more intelligent as a chess player than I am, because he will always beat me. But one of the reasons is that he performs more operations in less time. A lot of this, if you ask him, will be very intuitive. He just sees the best move in a way that would be inaccessible to me. For me to find the right move, I will have to perform a lot of like very cumbersome conscious work, right? Calculating different paths and so forth. And whereas Garry Kasparov can run many operations in the background of his mind due to his training and so forth. However, AlphaGo and AlphaZero, of course, right? So the most recent AI technologies applied to games such as chess and famously Go more recently, these machines are way more intelligent than Garry Kasparov by psychometrical methods. We can actually measure how much more they are intelligent because there is a good discipline of measuring chess intelligence, the so-called ELO system. And we can demonstrate that these systems are way more intelligent than Garry Kasparov, given the tasks. They will find the best moves much faster than Garry Kasparov. And if they both have tournament time, 2 hours for 60 moves, and then an additional 30 minutes, which is the standard tournament time for chess, then Garry Kasparov stands no chance, just no chance against AI systems. So in that respect, we have like many cases where AI systems are already more intelligent than human systems. However, let's be more careful at this point. If intelligence is the capacity to solve a given problem in a finite amount of time, then nothing, no system can be intelligent that doesn't even have a problem. So the question that of human versus machine intelligence or human versus animal, other non-human animal intelligence, that question depends crucially on whether a given system can so much as have a problem. The AI philosopher John Haugeland has called this giving a damn, right? So the question is, can AI give a damn? So Garry Kasparov gives a lot of damn when it comes to winning a chess tournament, right? It matters to him. However, it doesn't matter in the slightest degree to my search algorithm what I search for. So there's just no one at home, there's no mind in my machine in the way in which I have a mind. So there's a legitimate suspicion that there cannot be such a thing as artificial intelligence if that presupposes the existence of someone to whom something can matter. So this will play a role in the third part of my presentation, right? So everything will depend on the ontology of the kinds of systems that we create as a consequence of AI research. This is why I now move to the second of my topics, artificiality and the human. So current AI systems run on a certain hardware. And we have this hardware, because there have been very impressive successes in physics in the last 200 years in particular. Modern theoretical physics, quantum mechanics, and so forth gave us semiconductors. So without a lot of deep insight into how we can manipulate the electromagnetic field of the universe, right? How we can store information with the help of chips and processors and all the kinds of things that you get to see when you look into a server into the whole artificial architecture that we need for AIs to run, this whole architecture is by its very nature non-biological. Currently, this could change in the future, but currently we don't use organic matter, clearly not living matter, right? In our computers. If you open any kind of server, you will not find neurons or literal cells. You might find something that is relevantly similar to neurons or to brains by some mathematical metric or other, which a lot of advanced AI research does, but you will not find literal cells. Fortunately, it would be kind of scary if you opened your computer and there would be a kind of brain spread out over chips, right? That's not what we have right now. So AIs, the artificial part, refers in my reconstruction to products, non-biological products of human industry. That is the sense of artificiality. And we can produce them, like in an industrial way. So there's a crucial part to AI research that goes, of course, beyond the mathematical sophistication that you need in order to produce algorithms and so forth. You also need a lot of hardware sophistication, Moore's law and so forth. You always need smaller chips in order to store more information, et cetera, et cetera. These processes need to go hand in hand. And none of this gives us any indication that the systems that we have created are intelligent in the way in which humans and other animals are intelligent, because we have no indication whatsoever that anything matters to our servers or to our hardware. They don't give a damn, to repeat the phrase by John Haugeland. And giving a damn, I'm just mentioning this for those who might be familiar with a bit of philosophy of AI, giving a damn need not presuppose consciousness. There has been a lot of debate in the past about the relationship between consciousness and intelligence, but I'm not necessarily speaking about consciousness. No one knows what consciousness is, right? So consciousness is much harder even than intelligence, because at least I just gave you a sense of intelligence in which we arguably are able, right, to model the kinds of processes that are intelligent in human animals, but we have no clue how we could model the kinds of processes in human animals that are accompanied by consciousness or that produce consciousness. We don't know. There are interesting reasons why this is so. It has something to do with the complexity of the brain and our methods of making the brain visible and so forth. They are much more limited than AI research for various biological reasons. So let me come to the third and final concluding part of my presentation. AI as a thought model. So if AIs are not literally intelligent in the way in which humans and other animals are, then what are they? Because they compared to us, right? They are very good and oftentimes already much better than we are at performing certain tasks, right? So they look incredibly intelligent. For all sakes and purposes, they are becoming more and more indistinguishable from clearly intelligent operations. Nell has given us some very wonderful examples of how we're moving into like a world of deep fakes and so forth, right? So, already we are at a point where we can, start ascribing very high levels of creativity and so forth to our algorithms, in particular in the context of deterministic games like Go and chess, where the moves performed by advanced AIs, count by the best measurements as incredibly creative. The art case is more complicated, but in the game case, I think, these descriptions are fully warranted. Now, what are AIs then? What is the ontology of an AI? And now I want to argue that AIs are models of thoughts. So human thought provides data for AI systems and so forth, precisely because what we do is the target system of AI research. Modeling is not trying to copy something. A scientific model of a target system is not a photograph or like a literal copy of that system. That would be incredibly useless, right? Remember the good old problem of the map and the territory. A map scale 1:1 of California would not be very useful. It would just be California. So if you have a map of California that is of any use, then that map is going to be very different from California, right? You can travel in California, but you cannot travel in a map of California. Yeah? So maps serve an entirely different function. However, maps can bring out features of California that would have been invisible to us, right, had there not been the map. And I think that AIs function in this way. They give us models of human thought. That's why the history of AI is closely related to the history of philosophical and mathematical logics. Nell quoted Whitehead, one of the best logicians of all times, actually. It's not a coincidence, right, that his whole metaphysics and the very important point that Nell quoted is based on the history of logics, precisely because AI came out of an attempt of humans to think their own thought. Yeah? So philosophical logic, since Plato and Aristotle, deals with thought thinking itself. And AIs are similar to human thought thinking itself, except they are pure models. Yeah? And this is not their weakness, right? So what I'm saying is not, look, AIs are not really intelligent, right? Therefore, these are weak systems. What I'm saying is AIs are thought models, and therefore they are very powerful systems. It would be a weakness of AI research if it tried to copy human intelligence, right? So I want to insist on the significant difference between a model and a copy. Yeah? And then I can have both the good old philosophical cake, there is no AI, and eat it, right? However, there are real AI systems that are incredibly powerful. Yeah? That's the kind of view that I'm offering to you. If I had more time, I would tell you more about the human and why I think that in humans, intelligence is a sense modality, like taste and touch and so forth. I think human thought is a sense modality. Cognition is not opposed to perception in humans. That's a long story. And but this story might be useful for further AI research because it would give us even more to model. Unfortunately, a lot of AI research is still based on the misguided philosophical ideas of empiricism. And if we fed a better philosophy to AI research, then I think it would even make more rapid advances. So I will stop there and leave the rest to an exchange of ideas with our audience.
Thank you very much for sharing your perspectives and distinctions on these terminologies, Marcus. You almost asked or answered my first question. So we're soon gonna jump to a Q&A with the participants, but I want to sort of ask maybe both of you a first question, and that is in making these distinctions and being more aware of what you just presented. Do you think that will benefit the development, both the technology, but also maybe more laws and policy making around these technologies in sort of understanding what you just said? Would that help policymakers make better decisions going forward, do you think?
Oh, absolutely. The more realistic our understanding of ourselves as human, intelligent, embodied creatures is, the better our thought models are going to be. If we understand the target system better, right? So if we don't have mistakes in our self-conception, right? Then we reduce the risk of bias in algorithms, which is a famously big debate in AI ethics, right? How can we get rid of bias in algorithms? And one good way of reducing bias risks is having a better philosophy than the one that was available to early pioneering research in AI. Yeah, Whitehead is already like I was very happy to see Nell quoting like a really good philosophy source, because quite often, if you look at some of the kinds of things that AI researchers look at in the history of philosophy, they will pick very weak philosophy as their starting point. And so we need really good philosophy as the background, because we need to understand ourselves as human agents and then start adjusting our models to ourselves. There's the famous value alignment problem. How can we create AIs that serve our purpose, right? Precisely because we don't share interests with them, how can we guarantee that they're not going to destroy us in some unforeseeable way? So how can we make sure that this is not going to happen? And I think one good recommendation is bringing more like advanced philosophy to like very advanced AI research in the design process, not as a comment, right? Philosophers shouldn't just comment on what AI is doing. That's not interesting. I think we should like really cooperate on the business level. I'm doing this myself. I'm working with, you know, Deloitte, but also like the government of my state on an AI certificate process. I think that's what we need to do, like have philosophers in the lab and people from the lab also in the philosophy class.
Thank you. Jeanette, are you ready with some questions from the bigger audience?
Yes, I went through the whole chat and there is a big discussion about does intelligence need a body? Gregor Braun, maybe you want to unmute your microphone. Gregor?
Yes. Hello.
Hi.
That was within a discussion with, I hope I pronounce it right, Javier and Jacob, or Jakob, I guess, Jakob Svensson. And I thought I understood them, what I thought and I understood from their arguments was that they wanted to say that it needs a biological body to have things like emotion and intelligence, but as far as we discussed now, they are saying it also could be a robotic body. It doesn't need to be a biological one, but the aim should be not to just perform certain tasks artificially, like doing it with algorithms, but going more into getting artificial intelligence based on what human intelligence is meant to be, like having artificial emotions and sensory data that is more related to yourself and not just to problem data that is provided to an algorithm to achieve something like a real artificial intelligence. That was our little discussion there in short.
If I may, I do think that actually emotions are an important part of cognition, and that if we were to emulate something like emotions within machines successfully, that would probably advance the capabilities of AI to a significant degree. You see, emotions are in many ways a heuristic. A heuristic means a kind of an imperfect answer, but one which is good enough in a short time frame. And so if it's late at night and you hear a loud noise, it's a good heuristic, you know, to get like a little bit freaked out so that your body releases a bunch of adrenaline and primes you to take action, whatever that action might be. And so emotions are a great way of making quick decisions, or of priming us to take action, whether that's to take action to defend ourselves and our loved ones, or to nurture them for that matter. And I think that that is something that is lacking in artificial agents today. And if we were to be able to bring a little bit more of that, I think that would be a significant benefit.
Yeah, I couldn't agree more. If I may join this, am I on? Yeah. Okay, good. Yeah. I think that emotions, what we call emotions, that's obviously an expression of our adaptation to our ecological niche, right? I mean, so clearly the basic emotions in animals such as us, right, serve precisely this kind of function. So it's just incredibly useful, that's why we're still around, like to be afraid in the dark. Precisely because we cannot really distinguish objects in the dark, right? Our like sensory system gets attuned to like different kinds of clues in the environment to protect ourselves from potential danger. And in this way, our prognostic tools, our heuristic has developed. And this is a crucial component of exercises of intelligence in humans. Because, just take your subjective visual field. The kinds of things that are salient to you, that stand out as important, right, are among other things a function of biological selection mechanisms that pre-select these kinds of things for your conscious attention. That's why your subjective visual field will be pre-structured by lots of your, expectations and your experience and so forth, because we are adapted to our environment. And the more, we are able to model these features of animal life in an AI, the better it will be in solving object recognition problems. Because we are incredibly good at that due to millions of years of evolution that have been built up into the animal shape, the phenotypes, from which we profit as mesoscopic, products of the universe. And indeed, it's very hard to do, but not impossible. All will depend, of course, on on which kind of scale do you start modeling the system and so forth. And I think this is part of why AI research is currently moving so rapidly, because many dogmas that played a role in the past due to technological limitations and so forth have now been overcome. The field is very creative, and this has become more creative in the last decade.
There have been also two questions about AI and art. Will AI ever write poetry? Maybe Emily Long, you can ask your question personally. Emily?
Hi, I'm here. Hi, thank you so much. We were having an interesting discussion in the chat around this idea of the give a damn element, whether or not AI was capable of writing poetry and also of creating art or music.
Yeah, do you want to go first, Nell, or I can say something about this?
Okay, no, I'll take it on a practical level. Certainly, we have machine intelligence techniques at the moment which can replicate a little bit like the style transfer thing I showed you, turning a simple sketch and applying one of the styles of the great master painters to it. So we can create something that sounds like a Frank Sinatra song, or create something that sounds like a Beatles song, for example. But to actually create something that isn't merely a mimic or a simulacrum of the real thing, I think that's probably going to be beyond AI, unless we start to have AI that is truly able to think and feel in a similar way as we are, as well as being sufficiently pro-social to understand the experience of the reader, of the receiver of that media, right? Because poetry isn't just what's written on the page, it's what is evoked in that other person. And that requires an extreme level of empathy, usually, in a great poet. And that's why I think it's going to take a very long time before AI can write a truly moving poem, if ever.
Thank you so much. That's fascinating.
Yeah, I have in order to fully, I agree with Nell, but in order to give a full account, of course, we would have to talk about, the ontology of artworks. So what is an artwork, right? Do artworks necessarily, require humans to produce them? Clearly they require humans to interpret them. So you can't have a poem without a human interpreter of that poem or an artwork. And poetry requires a different kind of analysis for these questions than painting. So arguably with poetry, depending on where you stand on this, what your theory of the nature of poetry is, you might say that poetic meaning, right, is clearly very different from non-poetic meaning. If I, if I just give you a boring prose sentence, such as the ones that I'm currently uttering, then the meaning ascription, right, will be much more straightforward, right? I try to use words in a way that I assume you just understand them. But if we're in a poetic context, then I will start slightly changing the meaning of words. So a very good poet, like has a sense of the distance between the non-poetic meaning of a term and a newly invented meaning. That's why poetry can strike us and really, as it were, change our worldview. And so AIs could only do that if they understood semantic meaning and knew how to like measure a distance from, normal meaning, as it were, everyday meaning, and poetic meaning. But that means that they basically would need to be, take part in the human life form. What is already possible is, of course, that, we can run an AI and produce something that someone will think is a poem. That can, of course, already be done. But the question is, right, really, will we get something like Shakespeare? So you read a bunch of like Shakespeare tragedies, or you see them on stage, and your whole, sense of reality changes. And so far, we haven't seen anything like that from AI, where you see an AI-produced tragedy, and you suddenly understand, the 17th century or something like that.
So I have one last question for you, Marcus, from Lena Vucinovic, I hope I pronounced it right, about AI with motivation. Maybe you want to ask your question personally, Lena? Lena? Maybe she has left already. Then I will have as a last question from Flavio Cardoso. Will AI ever be conscious? Flavio?
Hi, I'm here.
Hi.
Yeah, I'm interested in that question because it's obviously, I think it's the next frontier, right? The next limit for AI. If we're ever going to reach consciousness, so if we're ever going to be able to recreate consciousness, I think that's a big important question.
Shall I begin on this?
Please.
I think that consciousness can be described as an operating system for a mind, or perhaps kind of a send information and resources here location for a mind. It is a sort of a converging point, or a way of getting a mind to be self-reflective. And I think that it might be surprisingly simple, or rather that we might stumble upon creating a conscious form of machine intelligence. I suspect that it might be a surprisingly silly little short circuit required in order to enable that. If we ever can understand the meaningness of what enables consciousness. But I think that it is definitely possible. And my reasoning for that is that I have a model of human beings as being essentially a form of biological intelligence, or biological artificial intelligence ourselves. Perhaps a sort of anthropic intelligence instead of artificial intelligence. You see, we have 86 billion neurons, give or take, in our brains. And yet, if our brains don't grow up in civilization, a feral, wild child doesn't really explore the world in a very humanistic sense. And yet we can also take dogs, for example, and we can even teach them our languages, and we can teach them right and wrong to a limited degree. and even get them to feel shame whenever they do something that greatly displeases us. And this means that really what makes us human is not the hardware. It is rather the software. It is the cultural data set which makes human beings. And this is why I consider humans to be a form of AI, which is instanced upon the hardware of Homo sapiens. So we are the instance, the software running upon the server of this primate, you see. And so if we are a form of artificial intelligence created from a cultural data set, and we are conscious, or at least we believe that we are, then surely we must be able to make other forms of artificial intelligence which are equally conscious.
Sorry, can I add another question to that? Well, I think it's very interesting what you just said. And this one is actually a religious one. I'm going to risk myself to it because I'd like to view this point of creation of another conscious being as something a God would do. And do you think that would somehow prove the existence of some different entity that might have created consciousness?
Well, I can take this, but I don't want to go too much into the God stuff. That's very complicated. I have views about this as philosopher and so forth. First, I agree with Nell about the fact that something very important about us, in a sense, what makes us humans, is indeed, so I agree to the, that there's a sense in which we are artificial intelligences. And that's why in a book of mine forthcoming, The Meaning of Thought, I have called AIs AAIs. They are artificial intelligences, and we are just AIs. We are artificial intelligences, right? And the way in which I introduced the point is quite similar to like what Nell has said. However, with consciousness, I'm not so certain if consciousness is on this level. So it might be that consciousness is something that we have created by way of like certain cultural practices. This is more plausible if we tie consciousness, like Nell did at some point, I think, to self-awareness, which is one of the prominent theories of consciousness, the so-called higher order theory of consciousness. According to that view, a state is conscious if there's some other state that is directed at that state. That's one of the prominent views of consciousness in contemporary philosophy, but it's old. It has been introduced by the German philosopher Johann Gottlieb Fichte in 1794. He was the first to make this point, and currently it's defended most prominently by philosophers like David Rosenthal and others. That's a prominent theory. But if there is consciousness without self-consciousness, so if consciousness is more like, feeling an itch or having a color sensation of red or an emotion, if this is consciousness, then it might be natural. Then consciousness might not be artificial. But maybe our conscious states, our actual conscious states, the ones of our participants, are probably hybrids of like purely biological things, right? And complicated cultural elements. So a lot will depend on, how much of our conscious life is biological and how much isn't. And in order to answer that question, we would need to find the so-called minimal neural correlate of consciousness, the MNCC, and you get this in the following way, right? So we know that the cerebellum, which is lots of neurons, right? If you take out the cerebellum, right, which is a huge part of your brain, you're still conscious. So the question is, what part of your brain do you need in order to be conscious? I can take out some neurons and I'm still there. But which part is the one I cannot take away? That's the MNCC, the minimal neural correlate. And once we have found that, we don't know what it is. No one knows what it is right now. If we found it, then we could come up with a view about, to which extent is consciousness natural and to which extent does it belong to our artificial side? I agree with Nell that in principle, there's no limit to artificially modeling human culture, the conscious, the self-conscious side, right? That should be possible to like an infinite approximation. Yeah? And this makes AI research somewhat similar to theology. Yeah? But so the other question is going to be how much biology is in human consciousness, and that's currently completely unsolved in neuroscience and philosophy. We just don't know.
Thank you very much, both.
So we have to come to an end, unfortunately, because it's a very interesting discussion. Thank you very much, Nell. Thank you, Markus. Thank you, Martin. I also want to mention some of our upcoming lessons. We will speak about AI and AI and art, AI and ethics, AI and bias, as well as AI and human robotic interaction. This will be the topic of our next session. We will invite Sami Hadatin from Munich and Kate Darling from the UK, and I'm really looking forward to this session. And yeah, I hope you will join us again. I hope that you spread the word and that you maybe also share the couch lessons through your social media channels. And yeah, hope to see you again and have a nice evening or day, wherever you come from.
Thank you.
Bye.
Thank you all very much.
Thank you. Thank you. Thank you.
Goodbye.
Thank you.
Bye-bye.
Thank you. Bye.
Bye.
Au revoir, à bientôt.
Bye bye.
Au revoir, à bientôt.
Bye bye.
Slecht.
مع السلامة.
Ciao.
Bye bye.